Welcome back again to another learning video. Today, we're going to dive deep into something pretty exciting in the Java world, the brand new release of JDK 25. Okay, so right off the bat, let's get one thing straight about this release. Java 25 isn't some massive revolution with a ton of brand new shiny features. Think of it more as a powerful evolution. It's all about taking these huge, important projects that have been in the works for a while, making them super stable and cranking up their performance so they're ready for the real world. All right, so let's jump right in. We'll start with the features that have finally graduated. You know, the ones that are no longer in preview and are officially baked into the platform. These are the things you can start using in your production code today. First on the list, stream gatherers. Now, if you've ever pulled your hair out trying to wrestle a complex stream operation into submission, maybe trying to write a really complicated custom collector, yeah, this one's for you. Gatherers basically give us a super clean, standard way to build our own intermediate stream operations. It just makes those tricky data transformations way simpler. And wow, just look at how clean this is. This little piece of code says it all. We've got a simple stream of numbers, and we're using the built-in window fixed gatherer to group them into pairs. That's it. No crazy boilerplate, just a nice, clear, declarative pipeline. It's just so intuitive, right? So why does this matter? Well, it matters a lot. Now that this is finalized, it means we can build way more expressive and efficient streaming pipelines. We can finally throw out some of those, let's be honest, pretty hairy custom collectors we've all written. And we can easily handle common patterns like batching data or creating sliding windows. It's a huge quality of life improvement. Okay, next up, and this is another big one that's now final, the class file API. For years really, if you needed to mess with Java bytecode, you had to reach for a third-party library like ASM. There was no other way. But now, Java has a standard, built-in API to do it all. And let me tell you, this is a massive deal for anyone building tools, frameworks, or compilers that run on the JVM. And the benefits here? They're pretty clear-cut. It means simpler bytecode manipulation with a standard solution that everyone can just rely on. It's going to empower the entire ecosystem of tools that dig deep and work at that low level with our code. All right, let's switch gears. We're moving on to the next major theme of JDK 25, and this is where things get really interesting: performance and concurrency upgrades. Honestly, this is where some of the most exciting stuff is happening.
Man, this slide really puts things into perspective, doesn't it? For literally decades, if you wanted Java to talk to native C or C++ code, you were stuck with JNI, the Java native interface. And let's be real, it was complex, it was error-prone, it was unsafe. But now, with the foreign function and memory API getting stabilized, we have a safe, fast, and just so much simpler way to do it. This isn't just an improvement, it's a total game changer for native interop.
And speaking of modernizing the platform, let's talk about scoped values. You can basically think of these as the modern replacement for good old ThreadLocal variables. Especially now, in this new world of structured concurrency and virtual threads, we needed something better. Scoped values are that something better, a much cleaner and way more efficient way to share data across threads.
So, why are they better?
Simple. For one, they're just faster. They also lead to cleaner, much more readable code. But the real kicker? They propagate data immutably and safely across all your async operations. And that is absolutely essential if you're trying to build robust, modern concurrent apps.
Okay, for anyone out there running big, latency-sensitive applications, I'm looking at you, cloud deployments. The improvements to the Z garbage collector or ZGC are just huge. JDK 25 keeps tweaking and refining ZGC, and the whole focus is on one thing, pushing that latency and memory footprint even lower. And this chart gives you a pretty good visual of the impact. What are we looking at? Well, we're seeing much more consistent and way shorter pause times. We're seeing a lower memory footprint and overall less GC overhead. What does that mean in the real world? For things like microservices and cloud-native apps, it translates directly into better performance and, yep, lower costs. And of course, we can't talk about concurrency without talking about Project Loom, right? Virtual threads were finalized back in Java 21, and they're not done getting better. In JDK 25, they get even more love, enhanced scheduling algorithms, even less memory usage per thread, and faster startup times. They're just more efficient than ever before. Okay, let's pull back for a second and look at the bigger picture. All of these individual features we've talked about, they're not just random additions. They're all part of Java's long-term evolution. And JDK 25 really feels like a major milestone for some of these key projects.
And a perfect example of this is the Vector API. I mean, this thing has been in development for more than 5 years. It's gone through so many rounds of incubation and feedback. And now, in JDK 25, it's finally getting close to its final, super powerful form. It's ready to unlock some serious hardware-level performance.
So what's new here? Well, the latest version supports new SIMD instructions, it has much better support for ARM architectures, and the auto-vectorization is even smarter. So who's going to benefit the most from this? Basically anyone doing high-performance computing. We're talking machine learning, scientific computing, heavy image and video processing, that kind of stuff.
You know, this table really tells the whole story of Java's recent evolution. Just look at the journey these features have been on. You've got the FFM API, going from an incubator project all the way to an optimized, stable feature. Virtual threads didn't even exist in 17, they were final in 21, and now they're getting even better. And look at stream gatherers and scoped values, completing that classic journey from preview to finalized. This isn't happening by accident. It's a really deliberate strategy of careful development, gathering feedback, and constant refinement.
Okay, so we've looked at all the different pieces. Let's bring it all together. What's the big picture here? What's the core identity of Java 25?
It really comes down to this one idea. Java 25 is a stability, performance, and finalization release. It's all about taking these incredible modern features and making them absolutely rock solid and lightning fast, so they're ready for your real-world applications. So to sum it all up, these are the main focus areas. We're seeing a relentless push for raw performance, especially with the cloud in mind. They're maturing the whole modern concurrency story with Project Loom, and they're giving us cleaner, more powerful APIs for basically everything, from native code all the way to stream processing.
And that really brings us to the final question, and it's a question for you. With all these powerful new tools now officially production ready, everything from stream gatherers to the FFM API, which one are you looking at and thinking, yeah, that's going to be the first thing that transforms my code?
And that's a wrap. Thank you so much for watching this quick explainer on JDK 25. I really hope this gave you a clear picture of how Java is evolving and just becoming more stable, more powerful, and more production-ready than ever.
I would absolutely love to hear your thoughts down in the comments. Let me know which feature you're most excited to get your hands on. And hey, if you found this useful, do me a favor and hit that subscribe button for more deep dives into the latest tech. I'll see you in the next one.